Okay. Satellite. You hold that.
I think this is a very interesting question. Maybe in the science side, many people may not be knowing. But a lot of information has already come in the press regarding the equipments which are there. See, we are focusing on specifically two areas to find out the geophysical or chemical characteristic of the thermophysical and chemical characteristic of the regolith, the surface of the moon. Second is we are trying to study the very close atmosphere connecting to the near to the surface of the moon. These are the two areas of interest. And we want to study this only towards the south pole. So this is the added interest. Because this area has been well studied in the equator, so we are trying to study towards the pole. The possibility is that this area is still not explored. And we are going to study the elemental composition of the regolith using two important instruments on board the rover. We are also studying the electrostatic electron, the special nature of the atmosphere. There is no atmosphere to say, but there is a charged domain very close to the surface, which varies with the day and night variation. So we want to study it using a specific instrument. We are also going to put a seismic instrument on the surface to look at the small level vibration that will be generated due to various activities. Could be a seismic activity or hitting of an asteroid or on the surface of the moon or whatever. So, and we are also doing a thermal conductivity and its electrical measurement of the surface of the moon by piercing a probe into the surface. So now it will look, these are the type of measurements. Then what is unique if you ask? I can tell you many of these are not, it's very unique, nobody has done before. For example, nobody has done this thermal conductivity measurement of the surface of the moon by inserting the probe that we have done today, which will give you a good understanding of how heat is traveling from the received on the surface is going inward. What type of the thermal characteristics of the moon can be well understood, which is very important. Even the very low atmosphere or the charged atmosphere is not studied very well in the earlier past. Even you look at the seismic study, there were some instruments which earlier looked at. This is very high sensitive instrument which has an ability to even look at even small pebble hitting on the surface of the moon. It may capture in terms of the shock. So, and the elemental composition. Of course, this is very important for us to understand the origin of the moon and also where from it, what is the nature of the materials there and how we can utilize it for future building of it. So there are some uniqueness. But uniqueness will come out of the data finally when you are going to get. If the good data is good and if the scientific people are able to deduce something out of it, of course the value will be much higher. Regolith is the only thing that I can access today. If I want to access the core of the sun, moon, I cannot go inside. At this moment, the access of any scientific instrument is within the regolith. So, this regolith is a creation over the many millions of years of deposition happening or any activity happening. It may also give some clue to the origin of this. That's why regolith is important. It's like studying earth using the sand which is readily available. Yeah. Okay. So what we are doing today is that we are still not submitted the project report to government because the architecture of the LUPEX is still not fully reached. There are many challenges. First is the mass of the lander which they have defined is slightly higher than our current capacity. So we are looking at how we can meet that goal and we are negotiating how we can bring down the mass. So this is one area. The landing craft has to be ours, is it not? Yes. The lander is a propulsion lander and theirs is a rover. They will supply a rover but the rover mass is higher. So the lander has to lift it and take it and land it. So overall mass being higher, the current engines which we are using for this Chandrayaan 3 cannot be used. So we have to develop new engines. So we are looking at how we can manage with available technology capability. So this is another challenge. So currently this process is going on, various options are worked out and we are discussing and we are trying to minimize our money part of the cost. So that exercise is going on. Both the people on my right and left side are doing this work. So they will come back to me again with a little more detail. Until then, please wait.
One question to Dr. Unikrishan Nair.
Here we have on podium the director of ESSC, Dr. Unikrishan Nair, the mission director Mohan Kumar, director of LPSC, Dr. Narayanan, Director of our UR Rao Satellite Center, Shankaran, the Chandrayaan 3 Project Director, Veeramuttavela is all on the dais. So you can ask questions, and of course the Director of SDSC, Rajarajan also. No, Veeramuttavela will be there. So we are here for answering some questions, clarification, etc., which you couldn't possibly when Minister was there. You technical things we try to minimize. Maybe you can ask some specific, technically deeper the pressure around that. That is the technique of measuring the speed. Or otherwise, you have to use something called an inertial instrument. But if the car is on the surface, the wheel is rubbing against the floor. So you can use it to count the number of times it rotating and measure the speed. But for a satellite which is in orbit where there is no air, there is nothing touching, how to measure speed? This is a big issue. So here what we do here, we are sending some laser beams to the surface, we are getting it collected back, and using this, we are calculating the speed. So it's a very new technique.